Okay, we're back. Let's talk about extending classes, aka inheritance. This is what you need to know really to be competent with Android development, actually, because you're extending classes all over the place. You do have to know how to create your own classes, but knowing how to extend base classes is kind of a necessity for the most part. We call it extending because we use the keyword extend. So here's the basic concept of inheritance. You can create new classes from classes you've already created, or from built-in classes is what they call them, built-in existing classes. So through inheritance, you're going to reuse the existing classes, the methods, the fields, and then you're going to add new methods and new fields to it. It's also sometimes called subclassing and superclassing. You have the superclass and you have the subclass. Subclass and superclass have an is-a. This is what it's actually called, is-a relationship that I've been talking about. And an object of a subclass is an object of its superclass. So think of super is on top and sub is underneath. But it's actually the exact opposite in terms of what you're doing, because you're building a base and then you're building derived classes that are at a higher level than the base, but you turn the hierarchy upside down and you have super and sub. So the subclass is this, the superclass is super in terms of its identity. A superclass is, let me start that over. A subclass is a superclass. A superclass may not be a subclass, depending upon which instance you're referring to. Not all supers are parts of all subs, because we can pick and choose who we're going to inherit from. So here's an example here, and it's a person. And the superclass is on the left-hand side of the screen here. Let me make this a little bit bigger. Use up all the real estate here. Make it a little bit bigger. That's pretty good. So we got a super versus a sub side by side. So we start out with a pencil and we make a highlighter pencil as in our example. Or we start out with a concept, and this concept here is a person. And person has a string of first name, or name actually. You can have a first name, last name, but this one just has a name. This should look familiar. It's a private string name. And this is a constructor, public person, default constructor because it's not taking on anything. Name is equal to not name yet, no name yet. Okay, and then we have a constructor again, and this one is setting the initial name. So the string is initial name, so we run this one with a name, and then we go this dot name equals initial name. And then we have string get name, string set name. This should hopefully be starting to look a little familiar to you. These are setters and getters to access and modify. And so we have name is equal to new name is right here. So this is what we did before lunch. And so after lunch, we're going to do this, which is a subclass. So it's a more specific person. So this one is called a student. So up to this point, it's all the same. Public class student. And then we can define a student all we want. Or we can take advantage of what we already have created. We've created a person, and isn't a student a person? Now, if we had a public class dog and public class cat, and we try to extend that and make it into a student, that might not make any logical sense. So we want to make sure we're making logical sense when we use the hierarchy and not just inherit everything. That's I've seen students do this actually, just inherit. So why are you inheriting? It doesn't make any logical sense. So you inherit so that you can keep everything that's part of a person and create a student that's a part of a person. So you have to think, if you're going to inherit, the class that you're going to create, the new one, has to be a subclass, which is why they call it a subclass. It has to be a subclass. Not all people are students. There's a ton of people out there who are not students. But all students are people at this university. I don't have any non-people students, no robots sitting in the room or anything. So I have that relationship for the subclass. All students are people, so it works. So just keep that in the back of your mind. You should have some sort of a subclass relationship. Otherwise, it makes no sense. If I said boat is an extended from cats, but not all boats are cats. Actually, I don't know of any boats that are cats. So So now what we got here, we have a private integer student number. So think of this as a student and a person. So if we have defined something in person, it exists in student. And the way, this is our key to inheritance right here before I forget, the word extends. So we put extends person, and then all of a sudden we've inherited, which is great. It's an automatic inheritance method. So in here we have a name and we have a student number that are going to work together. And then here we have public student, and then here we have super. Super is just like this. If I put this in here, I would probably put it down here. This means run the constructor of this constructor before I run the rest of this stuff, run this. So if you remember before, down here I put the word this, as it was the first line of the constructor that it was not the default constructor. And I ran the default constructor along with, so I ran more than one constructor. Well, this is also running more than one constructor, but it's calling super. This is the super class that belongs with this class because I've extended. I say I've extend person up here. So on the super class level, I have this, which what is this going to do? This is going to come back over here and run person. And it's going to set the name to name, no name yet. So every student that I create is going to have a student number that's going to be equal to 0, and it's going to have a name set to no name yet. If I don't do this, I'm not specifying which constructor is going to run, and actually I'm not going to get the default constructor anyway. So that means absolutely nothing, the reason why it's in there. But by practice, people put it in there, because what you can do is put it in here, more likely, and then you're going to run this constructor. Because if you run this constructor here, it's going to look for one over here with the same footprint. If it doesn't find it, it's going to run something. It's going to run one constructor. But if you don't specify anything by default, it runs the default constructor. Okay, so over here I have student, and I have another constructor here that's taking on a name and also student ID. And this is the part I wanted to show you here. It's sending the initial name back to super. So back to super here, it's going to run this constructor here. So this guy here, oops, super here, this is the first line of this method, by the way. This is just word wrapped. This is the first line of the method. This is just scrolled to the next line. This guy is going to run this guy. This guy runs this guy. Do we see that at this point? I hope. No, we're, yes, let me repeat that. Super here, this is going to run a constructor of the superclass. If we don't put any arguments in it, it's going to run this one. It's going to run person. If we put arguments in it, like we've done here, it's going to run this one. Why do we want to do that? Well, if we don't put this in here, this one's kind of optional because it's the default constructor and it will always run. If we don't specify any constructor at all, we're always going to have the default constructor run. But if we don't specify any constructor at all, we run this one to create the object. And now we have a string integer name and we have integer student number. We only have student number in here. What do we do with the name? We can't go super.name is equal to something, but we have name. That's going to give us a message because we have name. We could set the name here. We can actually go name is equal to something, but it's more common to see this. Use the constructors. It's more common to see super initialize. Well, what is that going to do? Initialize name person. When we say super, it goes back to person, and it sends this, and this came in from here. So it's a pass-through. So the subclasses methods are pass-throughs to the base class. This is the base class, although it's called a superclass. This is the subclass. It's the derived class, depending upon the terminology you want to use. And so we pass the initializations through. We let person initialize its data. We let student initialize its data. There's a couple of different ways of breaking all of those rules. Because you can go super dot this dot. You can go name is equal to something, because you have a name in here. But then you're not using the constructors. So the idea with the constructors with inheritance is to reuse the constructors. So one constructor is calling another constructor, and it's calling another constructor, because this is just a 2 hierarchy. You're not going to see that unless, well, in the beginning you'll see that, but when you have like 5 or 6 classes, and then you can let everybody initialize their own data. If you do that, then you won't have any data that's not initialized correctly. So for the same reason why you wanted to use the constructor to begin with. And then down here we have a get student number and set student number. We already have get name and set name. That's given to us already. So imagine in the subclass, just because we extend person, we take all this stuff, put them inside of here. So we can use it all. And we're going to pass the information from this constructor to this constructor. And then we're going to use any method we want from either one of the 2 classes. And they all work. So that's what we're going to do with dinosaurs in a few minutes, but that's the basic concept. So we have a class hierarchy. In the class hierarchy, every class is extended or inherited from another class. Whether or not it's declared to be, it's always inherited because everything comes from object. In other languages, you actually have to say object. And actually, when we created the class in Java, we extended object because we chose it from the list. And so now we can actually switch it around. If we want, we don't have to, if we have more classes, we don't have to inherit from object, we can inherit from another class. If a class does not declare explicitly that it extends any class, it is implied that it is extending object. So here's an example of the hierarchy where we have object, person, student. The is a relationship says that every one of these guys, every one of the students is a person and an object. Every one of the person is an object. The object is the object. It doesn't go this way, it goes this way, which is why the arrows are going up this way. This is why this is super and this is sub, the hierarchy. Alright, so fields and methods and extended classes. An object of an extended class contains 2 sets of variables and methods. It gets the fields and the methods that are defined locally in the extended class, and then it gets everything before it. It gets everything that it inherited from the superclass. So what are the fields for student object in the previous example? The fields are the data members. There's 2 of them. There's a name. Every student has a name, and every student has a student number. And it's all part of the student class. One of them was defined here, the other one was inherited. So oftentimes I see brand new students coming over here and go, private string name. Don't do that. Now you have 2 names. You have a name here and you have a name here, when you already have a name. And then you have to go, which name do I want? And then you get confused. Doesn't this object only have 1 name? If it's only supposed to have 1 name, don't reinvent the name. Otherwise you got this name copied to that name, copied to that name. And it's all 1 name. Alright, so the answer to that question is 2. There's 2 of them. Constructors and extended classes, this is where that super comes in. So the constructor of the extended class can invoke 1 or more subclasses constructors by using the super method. So if no subclass constructor is invoked, then the super is no argument constructor, or I call it the default constructor, is invoked using super. And it's invoked automatically as the first statement of the extended class's constructor, and constructors are not methods, and they are not inherited. Constructors are not inherited, which is a good point to kind of focus on here. We can't make a person from students. We have to create our own constructors for students that are different than the constructors for person. But our constructors can pass information back and can call previous constructors, and only the constructor calls the constructors. So I've had several students who try to call the constructor from the subclass. It doesn't work. Even if it's the same identical constructor, you still have to write it again. Not inherited. But what is inherited is anything else. Anything and everything outside of those constructors you get. Because do you get that? Because constructors are special methods. They're not really methods. They're not even considered methods. They're called constructors. And it's only to automate the building of the object. And each object needs its own form of building. And so unless you have your own form of building, it doesn't make any sense. 3 principles of object construction. An object is created, memory is allocated, which the initial set of values is default values are given or assigned to the variables in the allocated memory. And there's 3 phases. It invokes the superclasses constructors first, then it works downward. It initializes the fields using the initializers, anything that might happen to be there, and then it takes the bodies of the constructors. So long story short, it builds the object first, builds the person second, builds the student third. Which is why if you pass it back, which is funny because you built a student first. So you say, give me new student, and it constructs it from the start. It goes object, person, student. Because otherwise, how are you going to do it the opposite way? Because you don't know, until you've built the base, you can't build the drive, because the drive includes all of the base stuff. So it starts with the base, builds the object, and builds on top of that, and then builds on top of that. So it's the reverse, it builds it in the reverse, and allocates it in the reverse order that it is being instantiated. You don't really need to know that, but it kind of makes sense, actually. From a programming perspective, you don't really need to know what order everything fires in. If you're in C++, you do, but you don't need to know that in Java. To invoke superclasses constructors, it's executed using the same 3-phase constructor. So this process is exclusively all the way up until the object class is reached. So this little example gives you the constructor order. I have a better one. It's called purple and violet and colors. And I have some examples I'm going to show you in a few minutes that builds classes from classes. And then we're going to, after we look at some examples, then we're going to build our own, which is going to be that second assignment. And we'll get done on time, don't worry. Dino is actually pretty easy. The second assignment is a cinch compared to that first one in terms of the concept. If you look at this here, you can kind of get through class X and class Y extends class X. And then you have the information that's created, the variables and the data members. And you can see that this is the constructor here, and then we have a constructor over here. Constructor is the same name as the class, remembering that. And then we can look at the order. You can drive yourself crazy trying to do it manually with a piece of paper to go, well, which is the value of X and what's the value of Y, and which one gets created first and which one gets created second. Or you can do it programmatically, and it makes more sense. So we'll do it programmatically in an example, and we'll see this, because it'll make much more sense done that way. The only thing we have to do in inheriting class is decide which class we're going to extend, not do any extra work that we don't have to do, reuse everything we can as possible, and then we have to decide if we're going to override or overload. So overloading and overriding methods. We're automatically overloading constructors because we're rewriting them in the new class, and we're calling previous constructors, and we're modifying and supplementing the data that's being set with all those constructors. Overloading provides more than one method with the same name but different parameter lists. So we actually have overloaded already. When we created in 4 constructors in assignment number 1, we overloaded. It was all the same name, different parameter lists. That's overloading. Because we can call it and it'll pick which one we're running and run that one. So overloading an inherited method means simply adding new methods to the same name of a different signature. We'll see that in an example. Overriding replaces the subclass's implementation of a method with its own design. So to override, we replace it. Overload, we complement. Doesn't really matter if you know which terminology is which one. Just know that you can complement or you can replace, which is what you're doing. So in the replacing mechanism, both the parameter list and the return type must be exactly the same. So if we have a method called getName, and getName took on a name, and we wrote another one called getName, and getName took on a name, we're pretty much overwriting. We're replacing the first one with the second one. Anytime you use the same variable name, if I had person with string name and student with string name, I've done the same thing with the data. Now I've overridden it, so when I refer to name in a student, it's going to refer to the student's name, not the person's name, which means we're not inheriting anything, the name. We're reinventing it, we're overriding it. If you're going to override data, you might as well just not use inheritance, because you're not doing anything. What you want to do is overload it. So you reuse it, reuse it, reuse it, and reuse it, and just complement it, customize it. Okay, so an overloaded method can have different access specifiers as well from the superclasses, but only wider accessibility is allowed. So we can go wider. We can take something that's private and make it public. We just can't go public to private. When we talk about widening, we're talking about how much access are we going to allow. Public is the biggest. Private is the smallest. Protected is in the middle. It's kind of intermediate because it's both public and private depending upon what context you're looking at it. So you can go wider, you just can't go lower when you're overriding. And these are all rules you're never going to remember until you start using it. And then an overloading method can have different access modifiers. Okay. Overriding method of throws a clause can be thrown. Don't worry about throws yet, that's for exception handling, and we're going to see that in next weekend. I'm not going to talk about exception handling today. But the throws clause can throw them and be more specific. So accessibility and overriding. A method can be overridden only if it's accessible in the class. So here's where that protected comes into place. Private is private, and private in a base class is private. If you're going to override a data member in a subclass that you're going to create, then you're going to make the data member protected, but that's kind of rare. You're going to keep the data private regardless, because you're going to use the methods in that class to access it. So the set name, the get name from person is accessible all the way up through student and all the way past student. We just run get name, set name. We reuse the same method. No need to make that data protected. So it's going to be private. It can't be overridden. It can't be changed. So that's how we build in the integrity and the rules, and we make it so more solid. So if a subclass contains a method which has the same signature as one of its superclasses, then the methods are totally unrelated. Because it has to be. It's private. It's totally unrelated, which means we have two of them now instead of one if it's private. So some people make the private methods private inside of a class so it can't be overridden. It will always exist that way inside of the class. Otherwise, you stand the risk of it being overridden. If you don't want it overridden, make it private. It will never be overridden. If you want to open it up, you make it protected. So protected and public methods always will be not as simple as it seems, but they will always be public. And then protected means it's public to main, but, private to main, but public to inherited classes. We're going to see some examples of that coming up as well. So here's sample classes here, and we have class base. And then we have class concrete, one that extends base, and we have, we have some different methods in here that are going to return some values here. And then we have a show method that's going to run all of these methods, and this one's final, which means it can't change, and this one's protected, which means this guy can look at it and change it, but the public can't change it. I have a better example coming up that I'm going to show you in a few minutes. So I'm not going to run through this one because this is not very interactive. I can't see this one run. But if we did run it, we have this output that occurs. And it's because of, and the reason why we have question mark here is because it's kind of unusual. Because it wouldn't actually show what you'd think it showed. It's because we made something protected and then we overrode it instead of making it private. So protected is kind of, the lesson to be learned is protected is kind of not protected. It's kind of iffy protection. You might as well make it private if you really want to protect it. So it's kind of interesting that they chose the word protection for it. Like it's protected. Protected from who? Your subclass is going to totally destroy it. It can totally destroy it. It's just protected from the public. Anyway, let's not go worry about these examples. I want to give you the concepts actually. Hiding fields. So fields cannot be overridden. And these fields are the data members, as an example, so you can only be hidden. So person has a name. If you redefine name and student, you've hidden the first person. You've hidden name and person. Now you've got name and student. So a field can be declared in a subclass and it has the same name as the one in the superclass, then the field belongs to the superclass, cannot be accessed directly by the name anymore. That's when you go super dot, this dot. Because now you have two. If you're going super dot name, you're done something wrong. You should not do that. Because you've got two of them and you really only should have one. So polymorphism, an object of a given class can have multiple forms, either as a declared class type or as any of its subclasses. So I can take a student and treat them like a person. I can take a person and treat it like an object because it's all part of the same subclass. If it's part of the same hierarchy, that's another example of polymorphic behavior, is the ability to take the object and turn it into another object. And that other object is of the same family. So the question is, given the fact that an object's actual class type may be different from its declared type, then when a method accesses an object's member which gets redefined in the subclass, then what members of the method refers to the subclasses or superclasses? How do you know which method you can run or access between the hierarchy? Well, when you invoke a method through an object reference, the actual class of the object decides which implementation to use. It knows because it keeps track of all that stuff, and so you can switch back and forth, and you don't have to worry about it because it's dynamically allocated. It's already put into memory. You can switch back and forth. We'll see that as well. I'll transfer one class to another. I'm not going to look at this one. So type compatibility, a little thing on here. Java is strongly a type language, so part of the casting that we do is to make them all like types. So in terms of compatibility, when you assign a value of an expression to a variable, or you assign an object like person P is equal to new person, and then you go student S is equal to new student. Well, if you cast a student down to a person, now you have two, so you can assign one to the other, change the people, and then that makes it more compatible. But you can't use a student and a person together. You can't compare a student and a person because they're of different types. So we have type compatibility issues, which is where the casting comes into place. We also have the null character, null object reference. We've seen that actually in a couple of examples. It refers to nothing. It's not zero. It's not empty. It's null. So it means it doesn't point to anything meaningful. So it's compatible with all reference types. So we can say a person is null. P1, person P1 equals null. Or, or P1 is equal to null. Or student is equal to null. So in terms of the casting, we can do what's called upcasting and downcasting depending upon what we have. So if we make two references of two different objects, one is a person and the other one is a student, we can take the student and turn them into a person. But we can't take the person and turn them into a student unless we created them as a student, because it won't fit. The memory is smaller. When we create a student and a person. We have them both. When we create the person, we just create the person. There's no room for student in that memory address, so we can't cast it the opposite direction. So it's called a widening conversion. Those are good. Narrowing conversion is good. Widening conversion, you assign a subclass to a supertype. Can be checked at compile time. No action is needed. To narrow it, you're converting a reference of a supertype into a reference of a subtype. Must be explicitly converted through a cast, which is why I'm calling it a cast. Giving you a bunch of vocabulary, we'll see this live in a few minutes. So just hang in there if you're already lost with all of this. So two types of conversions. This slide is kind of a repeat, so I'll kind of use this slide as an explanation. The widening assigns a subtype to a supertype. Subtype was a student, supertype is a person. That's a widening conversion, that's okay. Narrowing conversion converts a reference of a supertype to a reference of a subtype. We'll see that in a few minutes. The casting behavior works like this. We put the type inside of opening and closing brackets here. So we have string, we created a string, str, and we took it, we created, this is using an object type. This is actually legal code. You can just create generic objects if you want. You can do this in JavaScript too, actually. JavaScript, by the way, is not full Java. In fact, it's a totally different language. It follows through some of the similar Similar object-oriented concepts, though, which is kind of interesting. And JavaScript is one of the very few, well, outside of Python and some of the other languages, it's one of the very few scripting languages that's object-oriented, or can be, if you want to use it that way. But you can say object1 is going to be equal to, well, take the string and convert it to an object. That works. And then you can go object2 is equal to str. It's equal. They're both equal. But down here, if I say string is equal to string object is equal to string 1, and I take a double sum over here, and I convert the object to a double, well, it's not a double, it's a string. So that's not going to work. So, all right, this example kind of goes through that stuff. We can also do this kind of thing here. We can see if the object is an instance of a string. Because the first thing people are going to go is, okay, if I can go one direction but I can't go another, then how do I know if it's safe? So I have all these students and I have all these other people. I have another thing. I have graduate student and I have student. How do I know they're all people? Well, I can test. I can say, is object an instance of person? So is graduate student a person? And it can come back with a true or a false. And if so, I can cast it. Because what is going to end up happening is you're not going to be able to remember the hierarchy. So this instance of allows us to check to see if something is an instance of something else. This is what I call intermediate level stuff. So program number 2 that we're going to look at momentarily, actually before I'm going to go through some other examples, but that one doesn't do any instance of stuff. It doesn't do any casting. Instead, we're just going to do a strict, straightforward inheritance kind of thing. And in the more the intermediate level, the next time you come back, if you come back, then you're going to have to take objects and translate them, cast them into other object types and use them together in an array or use them together to do something. And then you might want to refer back to the slides and say instance of is going to give me that. We're not going to do abstract classes this weekend either. This is what we're leading into for the next weekend and in a month from now. Abstract is not bad an idea to know what an abstract class is, however. Abstract classes and methods, nothing more than just regular old classes and methods, except for they're not implemented. And you cannot make an instance of an abstract anything. So it can't be used, but it's built for inheritance. Because a lot of people would say, why in the world are we going to create a full implementation of a person when we're just going to create a student from that? So if you make person abstract as an example, then we know all the grad students and all the students and all the engineers and all the janitors and all the teachers and everybody in the world is a person. Then we can just come up with a generic implementation of the person and then allow the customization to happen in the inherited classes and not put anything in the abstract classes. So, and we can actually supplement that with known stuff, with unknown stuff, and not try to implement something. An example of this would be something in having to do with shapes as an example. If I have a concept of a shape, and then this is the one I'm going to show you actually, and I inherit from the concept of a shape, I have a square, a rectangle, and a circle. I know I'm going to put an area method in there, but from a generic shape perspective, how do I know how to calculate the area? It's going to be different for a circle, a square, and a rectangle. So I leave it and I make it abstract. That means you must implement the area, but you have to implement it specific for a circle, a square, a rectangle, or whatever it's going to be. Actually, it's rectangle, square. But anyway, long story short, your implementation is going to be specific for the derived object. So if we make the abstract, in this particular case, we use the keyword abstract. So instead of saying public, we say abstract class person, abstract class shape. And we list a bunch of stuff in here. And they're sort of like prototypes, no implementation. We can actually supplement with implementation if we want. And then over here we say class student extends person. And then we implement everything. It basically saves us a certain step of not having to override that. I mean, we're going to override everything anyway, so don't implement anything. So abstract means it's not implemented. It's just a template that someone's going to use, and you're going to use this as a guideline. So you're wondering, well, why in the world bother doing this? It performs a contract. As an example, if you have a person as a base class and it's abstract, and you inherit an employee and a student from this abstract class, and you put in the abstract class there has to be a name and there has to be a get description method or something. If you don't implement it, then you get an error message. It requires you to implement it. So every person and, every employee and every student that is a person has a name, has an age, has a description. So it sets kind of a relationship where it requires certain functionality to be implemented. In that case, you're going to hopefully have some consistency and uniformity among the hierarchy. I'm not going to talk about abstract classes because we're not going to get into it, but I want to talk a little bit about protected members, data members. So it allows subclass methods to access the superclasses fields. You can define them as protected. But be cautious. Making methods protected makes more sense in the subclass if it's trusted. So the method is going to use it correctly, but other classes cannot. So make sure if you make something protected, you're opening it up to different interpretations and to different meanings and different assignments into the subclassing that's going to occur. All right, so I'm going to stop this and I'm going to repeat. There's only 1 or 2 slides left on here. Next time I see you, I'm going to start in with abstract classes. And we're going to write an abstract class and we're going to inherit abstract classes. But let's just look at the base concept of inheritance right now. So if you go out to the behavior.com website, I'm going to go down and look at some of these examples that we have started with. And I'm going to show you one more time where they're located. What I did, let me slow down here because I'm going too fast again. If from the main menu, click on Object-Oriented Programming with Java. I'm in the class. I'm in the course materials section. As a reminder, assignments is where we're getting this stuff that we've been looking at. PowerPoint lectures, the lectures I've been showing you. Lecture examples, right here. That's the one you want. If you scroll to the bottom of the list, these are the 3 that are for this weekend. Actually, the first 2 are for this weekend. I didn't know how far I was going to get, but I decided to go these 2. So, classes and inheritance, which are the 2. And they're zip files. If you download them, they're zip files, and I have them out here. This guy we're not going to look at. And yesterday, if you remember, we went through this one. There's another one in here I didn't cover, was boss and employee and main. And so what I'm going to do is I'm going to open up an Eclipse project. I create a brand new. I'm going to drag and drop like what we did yesterday. Put these files in there so we can talk about this a little bit. Because it's going to show us a couple of little things that are going to be different. We looked at Pencil, and we looked at Create Pencil, and we looked at Hello Java, and we looked at Hello World, a couple of different kinds. So I'm going to finish off this example right here. And this is nothing more than taking 2 objects and making instances of it in the same project. Whoops. Okay, so I have, let me make sure I close this. Okay, good. So go ahead, if you're following along, you don't have to do this. This is not the second assignment. This is just an example to demonstrate something to you. I closed this project that I was working on before, so don't confuse anything. Don't add this to your project. Close it, create a new one. Go File, New, Java Project, or Project, and then select Java from that. I'm going to call this one example classes. It's not an inheritance. I'm just going to quickly take a look at it so we know what it is. And just refresh your memory on how you're going to input stuff in. When I make this, I don't get anything. I get this empty source directory. And so remember, I'm refreshing your memory. Hopefully I've got main. I'm going to drag it in here. And make sure I put it right here. And I have a little plus symbol on here. I'm going to drop it. Unfortunately, I dragged it upward. And it opened up this JRE directory. I'm going to copy the file in. And I'm not sticking it in JRE. I'm sticking it here. It's going to complain because I don't have these 2 files in there yet, so don't worry about it. So I'm going to take employee and I'm going to drop it in here too. I have to open it up, however, in order to get the arrow to come in correctly. Copy it in. I'm going to take boss. I'm going to copy it in here too. Now all the red stuff went away and it's all happy. If I take a look at main, it kind of tells me what's going on. And this was built the same way as we built pencil and create pencil. And we built earlier today the temperatures in main. But it's going to show you two different instances. What do we have here? We have boss, my boss. And then we have employee, my employee. It's just an example of showing you the same thing we did earlier. But instead of having just one temperature class that we were working with, we have more than one class type. We have other stuff we're putting in here. And so this is nothing more than running a constructor. This is nothing more than running a default constructor. This is nothing more than printing out a get name, get salary, and stuff like that. So if you're looking for another example, you don't like temperatures, and it was too confusing for you, and you want to see something else, this is another example of a boss with a default constructor setting attitude and entry and stuff. And here's one here where it takes on another constructor, takes on the information, sets everything. And then we have a get salary, get attitude, get name. And then employees, no biggie. It's just the same thing over again. Not an inheritance example. It's the end, the last example that's in the first file, that sample number 1. And it's just yet another example of how to create an object inside of another object, and has 2 objects instead of 1. You can put in as many objects as you want inside of that main driver program. So I'm going to go ahead and say yeah. So I'm actually going to be sloppy here. I'm going to delete these guys and show you. So just the same way as I brought them in, because I copied them in, I'm going to delete them out of here. So I'm going to clean up the mess a little bit here. I'm going to just reuse this so I don't have to create another project. If I load them in individually and I don't put them in a project, I don't have the same scope for each one of the files, and then I get error messages. So that concludes the simple 1 or the sample 1 examples. In number 2, we have inheritance. So I'm going to bring in inheritance 1 and inheritance 2 and show you a few things. And I'm going to do them individually. They're not what I call ideal examples, because it's all in one file. And remember, before we had a main driver program, and then we had a boss, and we had an employee, and there's 3 separate files. This is just showing you a bad example, actually, of putting it all into one. Sometimes you see textbooks examples done this way, because then you don't have to, you can just cut and paste and put it in. But I'm going to show you the base concept here so you can get a feel for this. So don't do it this way, but this is what the example looks like. But it's put all together for simplification. So we have my base, which is a class. And then my base has private integer x. And then my base has a constructor. No default constructor. We didn't put a default constructor in here. I took a shortcut. But it has one that takes on an integer x. It says this dot x is equal to x. And then we have get x, which this is kind of like, like instead of a set x, we just put a get x. And then we have a show, and show is going to say x is equal to something. And then here's your big old inheritance mystery. It says class my derived extends my base. Well, here's my base right up here. So imagine this is in a separate file. Imagine this is going to be in a separate file. And then we have private integer y. So we're going to have an x and a y. And so my derived is going to take in an x. And then we're going to load x up into the super x. So this super x here loads the constructor of my base that has x as a parameter. We don't have a default constructor. We just have one that has x as a parameter. So it comes up here, and it's going to load this one up here. And it says this dot x is equal to x. And this is x. And then the reason why we had to use this in here, because this is going to give us an error message. What x are you talking about? This is why we use this. unless there's confusion, there's no need to say this. This has got a confusion to it. If I go like this and go x is equal to x, huh? What x are you talking about? This x or this x? So then we go this x. This x is this x up here. This x is up there, and then this x is this x right here automatically. If it's not this one, it has to be this one if there's two choices. So that's why you see this a lot. Otherwise, you don't see it. I don't put it in unless I'm going to solve a confusion here. Okay. So then we have another constructor. My derived has two constructors. It has one that takes on x, and then we have one that takes on x and y. And so we're going to send x back up here, and then I'm going to say this y is equal to y for the same reason why I said this x is equal to x, because I'm trying to resolve confusion. And then I have a get y. I don't need a get x because I got a get x right here. And I got to get y right here, so get x is an x in my base, get y is in my derived, which is built from, extends my base. So I have both of them together in here. And then in main, I'm going to run here, show. There's a show method that shows x and it shows y. And the show method is inside of my derived. And so inside of my derived I have a show, and show is going to say, well, let's just run getx. Getx is public. If it were private, we can make it protected and run it. But it's public, so we can run getx, and then we can just return y, because we have y, it's right here. And this. In fact, we can, if we wanted to, we could put this, but this is it's concatenation, so this is just text that's being printed out. So here's our main driver program. This is the one that's called inheritance1, which is why the file is called inheritance1.java. Although when we compile this thing, I'll take a look at it for you. Actually, I won't take a look at it for you. We're going to get 3 files out of this. Although all of this is in one, we're going to get a mybase.class, a myderived.class, and we're going to get an inheritance1.class. Kind of sloppy, actually. In fact, let me show you real quick. If I come out here and change to jp.simple2, and I see here it is right here, inheritance1. We don't have any. If I go like here and go start.class, there's nothing in here. There's no classes in here. So if I java c inheritance, spell it right, inheritance1. Now if I list out star.class, oops, if I spell it correctly, I have inheritance1.class, mybase.class, and myderived.class. So even though I put it all in one file, I'm still going to get those 3. And if I run it, I'm going to run which one? Well, that's the problem here. Oh, it's inheritance. This is the main driver program here. So inheritance1. Well, just leave it right there like that. And what this is going to do is going to say x is equal to 2, y is equal to 3, y is equal to 4. Well, what is that going to do? Well, here's what they were. We didn't go over this yet. So inside of inheritance in the main driver program, we are setting. So we have my base. In fact, here, let me run it here so you can see it side by side. My base b is equal to my base 2. So my base is up here, and I ran this constructor, and I sent it 2, so I have this x is equal to 2. And I'm going to go b.show. b.show is right here, and the show is going to say, well, what show is that actually? It's going to be this show, because we didn't create a derived class, we created a base class. So when we run show.show, from B, we're going to run this one here. And it's going to say x is equal to x. Well, x is equal to 2. That's where we get this from. So this is what happened here. No such thing. At this level, there's no such thing as my derived. We're never going to get any my derived behavior. We just created a my base. Okay. So down here we have my derived D. My derived D is equal to my derived 3, 4. So we're going to set an X and a Y because a my derived is also my base. And then we're going to show D. So this method here, the constructor is my derived. Come up to my derived. I have integer X and integer Y. I'm going to super back X to my base. I say X is equal to X. Well, that makes it X is now going to be equal to 3. And then now I have 4. Well, this Y is going to be equal to 4. And then the show method here is going to go X is equal to get X. And you're wondering, well, what is this get X from? I didn't do dot. I didn't do anything dot anything. It's just get X because I can run the method. Get X is from here. This is from my base because all derives are also a base. I can run a base method to get X. I don't have to reinvent the wheel. That's just going to return X. So down here I can see out, system out. This is going to return my X value, and then I've got my Y. So I'm taking my X here, and I'm taking it from my base class, and I'm printing it out into my derived class when I show it to the screen. If that's confusing to you, dwell on it, look at it, print it out, stare at it for a couple of days. You'll probably catch on. So you have to imagine this is why they make you take math classes. It's the level of thinking where you have to be able to like connect stuff together that helps you. So usually people like math people become really good programmers because they like, no, it's base, no, it's X, no, it's Y, no, it's, and they can figure out, they can follow it through. All right, so we have another one called inheritance 2 that I'm going to drag and drop over here and put it in here. And I'm going to copy it in here. And I'm going to delete inheritance 1 unless anyone has any questions with inheritance 1, I'm going to delete it. Okay? We don't need it anymore. It's on that downloaded file if you want to look at it. Inheritance number 2. Purple. I'm going to say purple and violet. Okay, so let me get rid of this bottom here so we can have full real estate view. People don't like X's and Y's, so let's put some color into this. Make it a little bit more meaningful. Not everybody, I like X's. Anyway, so purple, class purple. And keep in mind, I've kind of simplified this. This is really public class purple. If I don't put the public in, it is purple. I mean, it is public. Purple, I have integer I and I is equal to 0. And then I have a default constructor that says purple running and I is I. It's just going to print. It only has one piece of data associated with it. Doesn't make any sense what it is. It just says it's going to print it out. And then I can initialize purple. I can run a constructor that sends in an I, initialize that variable along with the constructor. And now it's going to say same thing, purple running and the I is equal to I. Now I'm going to create class violet, which extends purple. All violets have a purple. Okay. So in my violet constructor, I'm going to print out violet running I, and it's going to be equal to I. I'm basically doing the same behavior. And in my other same identical constructor number 2, it's going to say system out. I'm going to send it an I value. So purple and violet are doing the same thing. We just have a default constructor that just sets it, and then we have one that just says, hey, here's an I, initialize me with this I value. So here's main. We're going to create a violet, and then we're going to create another violet. Violet is the highest class in the hierarchy. Each violet also contains a purple, because we have a violet which extends purple. So the interesting behavior is shown on the screen. Let's run it. Purple running I is equal to 0. Violet I running and I is equal to 0. I should have put a line return in here actually. Let me put a line in here again. So you can see what's going on here. I'm going to create 2 new violets. The first violet that's being created is using the default constructor. The second violet is sending the number 4 to it. This is the one instance. This is the second instance. I just put a line return in so you can see the difference. So new violet, new violet. Where did purples come from? Well, each violet is also a purple. So with each violet, I also got a purple. But I didn't pass anything back, so the purples are all 0s, but the I's are all 4s in violets. I like this example for another reason. This allocated something, but it didn't assign it. So we have this thing called the object reference. As an example, I can go here. For those people who have looked at this and go, new violet. Well, I can make another one here and say violet, my violet equals new violet 1. This is the object reference. This is the object, but this is going to come back and say, hey, it's not used. Yeah, I know it's not used. The local variable is not used. It still allocates it. So let me do this here. Copy. I'll put another line return in between so you can see this next set that's going to come out. This one I initiated to the value of 1, so now I got 3 sets that come out of here. Oops, now I got, here we go, 3 sets that come out of here. I got the 0s, I got the 4, and I got the 1. But this one now has an object reference. So if this up here, which is protected, if this was public, I could go violet, I can do my violet dot I and print that out or something. I can run methods on that. But the idea is here we don't have an object reference. How are you going to get at it? You can't. So here there's something I can get at. I can go my violet dot 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 dot. I can do something with it. This is the reference to this new memory. These guys have no references. This one here has no reference. This one here has no reference. But it created it. And it will create anything you want. So this here is the assignment expression, as I mentioned before. So this here equals this here, which is this is the reference pointer to this. So unless we give it a name, we can't identify it. But in Android and in other environments, there's a time in which you just want to say new something. New content provider. I have a content provider. Now I have access to it. Now I can add and get stuff out of the content provider, and I can put stuff into the content provider. Am I really going to use it for anything? I'm not going to call any methods on it. I'm just going to see what's in there or something. So I can, like, the lightweight creation of an object without an assignment to a reference to the object. Think about that one. Dwell on that one. You might not like it. You might like it. Who knows? So let me give you a more traditional one that's going to essentially put some pieces together for you. And the last inheritance example that we're going to look at before we start Dino's. So let's take another look here. I'm going to remove this one. This one's called inheritance 2. Same thing applies. I'm going to have a, if I go out to a command prompt and compile it, I'm going to have a violet, and I'm going to have a purple, and I'm going to have a main. So. All right, so now I have to remember which one goes with which. Payroll. Let's try payroll first. So I'm going to drag payroll into here. It sounds like a driver program, doesn't it? That's why. Okay, so now you maybe understand why people use the word main in their main program, because I have to guess and say, well, payroll, that sounds, and then I go in here and go, oh, employee. Okay, so I know this one goes in here, so I'm going to drag employee over here too. And anything else in here? Dependents. Employee is going to need something. What's employee going to need? Employee is going to need person. So we got person. Oh, here's person. Drag person over here, put that in there. Oh, we have dependents. Let's put dependent in here too. I'm putting it all in the same package, by the way. So if you put it up here, it's going to create another package for you. Default number 1, default number 2. So I just took and I created the payroll program that has dependent, employee, and person. What's this other one? Read console. Let me take a look at this read console. Let's see what this is in here. I believe it's going to be our input. Buffer reader, yes. System in. I'll show you that later. I've been looking, okay, so for basic programming stuff, I've been showing a lot of output, but I haven't shown you any input yet. Read console is going to get input from the command window and bring it into the program, so it's the input. I've only shown you output so far. And actually for all of the assignments we're doing, we just need output. So, but if you wanted to ask the person to enter in a Fahrenheit or enter in a value, you probably need some input. Make this big so we can kind of look at this here. The base class is going to be person. So let's take a look at person first. Close payroll. There we go. So this is a typical hierarchy, and this is an example of what we're going to write next. But we're going to use a dinosaur theme instead. This is more fun. So here we have a person, and the person has a first name, and the person has a last name. Every person is going to have that item. So now you think, well, what belongs where? You know, well, if every person is going to have a first name and last name, but is every person going to be an employee? No, we have some people who don't work. So we can worry about that. And then we have a default constructor here. And you might wonder and think about this and go, well, why is this empty? In fact, sometimes you see it like this. Instead, you go, why is that empty? Why in the world is that even in there? I don't know. It's just unimplemented. I just decided to put this in here to throw you off because it's unimplemented. So you might put that in there and put a quote in here and finish this later. Or something. Or maybe you just don't need it. And you're just going to put it in there and go, hey, I have one. Okay. It's the default constructor. I could set first name and last name to empty strings or to null if I wanted to. Okay, so what am I going to do here? So I'm going to do something that's interesting, and I purposely made these constructors kind of funny in this example because I haven't shown you everything that you can do with a constructor yet. So some people actually kind of alluded to this concept the first time when we started writing constructors and say, if you have a set and a get, why don't you just have the constructor call it? I think you actually made that comment. I'm like, you could. So here's your example for that. I just hadn't gotten there yet. So here's person. Person takes on a string, a first name and a string last name. The only two things that the person does. And so instead of reinventing the wheel and going, this dot first name is equal to first name, and this dot last name is equal to last name, instead we just go, let's just call set first name as set last name. And so now we have a get first name, set last name, set first name. So here, and this is in the get first name, set first name, get last name, set last name. It's done this way. This code is providing us with this last name is equal to last name. This first name is equal to the first name. So why reinvent the wheel? You can just call the setters and getters from the constructors if you want, which is what this example is doing for you. All right, so that's the rest of the code, actually. Yeah. An instance variable to a constructor as an argument. No, because the constructors only trigger from main. If you created a main regular old variable that didn't belong to an instance, you could pass that to the constructor. But you can't pass something that hasn't been created yet. Yeah. So the answer would be no.
But possibly, there are two constructors I'm creating. Suppose I create T1 and I'm going to create T2. And while I'm creating T2, I can pass T1.
You cannot pass data between two separate instances either. It doesn't work. Instances have their own private data, and they can't share them. So what you can do is pass between, well, we don't see that, we're going to see this. We're going to pass from employee first and last name. No problem, we can do that. We can pass between different identities that are all part of the same is-a relationship throughout. We can pass between the hierarchy, but we can't pass between different instances, and we can't pass if the instance hasn't been created yet. Very good questions, actually. So let's take a look here. This is the base class called person. Imagine this is going to be a dinosaur. We create a dinosaur. And then we have employee. What's an employee? Well, employee extends person. But employee's got a lot more stuff in here. An employee's got, what has it got? It's got a net ID. It's got a static net ID, going back to that static stuff that, a variable that's shared among all the different classes. And then we have a department, a pay rate. What's this? That looks like an instance of another object. Where's that object? Well, that object's out here. So the object itself is containing instances of other objects. So this is yet another teaching example to show you that although main is creating instances of objects, well, so can other objects. They can also declare variable types or reference types to other objects. So I'm going to take a slight detour, come out here and take a look at dependent real quick here. Dependent's real easy, actually. Dependent is also a person. So now we have multiple inheritance going on here. Not multiple inheritance, we have multiple lines being established. We have a person is an employee, and a person is also somebody's dependent. We're all people, right? And so just like inheritance in the real world, employee has in the dependent, we have an object that is of an employee type. This is a circular relationship going on here, but it's not causing any circular problems. It just means your dependent, which is a person, inside of it has an ID, has an employee object that's identifying which employee it belongs to. It's kind of like how in the real world you have a parent and you ask the child, who's your parent? Oh, there's my mom, there's my dad. So you have the you know that information as a child. Well, that's all you're doing here. You're putting in here, it's dependent of who. Who is the dependent of? And unfortunately, you only have one person. Normally, husband and wife don't work at the same company. Usually one person does, either the mother or the father. So we don't care. We're just saying dependent of somebody, and they're the employee of the company. These are the constructors. So dependent has one that takes on the employee dependent of, the first name and the last name, because they're a person. And what's this doing? This is going to call super, first name and last name. Who's super? Person. Person super, because we're extending person. So we're going to extend and we're going to send the first name and we're going to send the last name back to person so we can create a new person. And then we're going to say this dependent of is going to be equal to the dependent of. And we're sending an employee. From main, we're going to create this dependent. And we're going to send the dependent information, which is, we're going to send the employee object. Same thing as we did with the other one when we compared. We wrote the comparison and we sent a temperature to a temperature. We say, here your temperature, here's another temperature. Well, we're sending here a dependent and employee object, so we can assign it correctly. This dependent of is equal to dependent of, and then we're just basically taking this employee. This is a reference type, dependent of, it's of type employee. So we have an instance of that object created here. And then this get dependent of is just going to return the dependent of. And you look at this and go public employee get dependent of, and you go, what in the world is that? I thought we were inside of the dependent class. We are. We're using employee as a data type. So this is as hard as it's going to get for this session. Because most people, I'm seeing some blank looks right now, and I have to tell you this is probably the hardest we've seen so far for this session. We're using a data type of an object inside of another data type of an object. It's actually all the same thing, it's just compounded, yes?
Maybe diagrammatic representation could help us to understand the hierarchy here.
A diagram would, actually. Let's see if I can do it. I can do it in Paint. I can do it on the board, actually. In fact, here, let me do that. It's hard to record what I'm doing, but I have a pen. Let's just do it. Let's see if this works, actually. Because if you understand, then this source code is going to make some sense to you. If you don't understand it, it's not going to make any sense. That's why I like rooms with classrooms with boards on them, because then you can actually do something. Let's see if I can get this so you guys can see it. Can you see it from here? Should I need to angle it here? Maybe move it back over here, actually. I think it wasn't a good spot to begin with. How about now? You can see it now. It just makes some rows here. Okay. We have person. Go back to this example here, actually, because I don't want to confuse myself. Okay, so we have person. That's an object. And person is being used in two different classes. It's being used in employee person, and it's also being used in dependent. So in person, we have this going on. Unfortunately, I don't have an erase right here. Let's see one on the back side. I'm going to abbreviate that dependent, because I can't spell. Inside of dependent, we also have an employee, but it's not part of the inheritance. So we sort of, I want to go like this, kind of, but I don't want to do that, because it's really not related. I want to do this instead. That says employee down there for those people in the back. It's inside of dependent, dependent. But it's not part of the inheritance. It's just created inside of it. So we have the ability to assign an employee to a dependent inside of main. Because in main, well, when we see main, I don't know if this example is actually doing anything. Inside of main, let's take a look at main real quick here. It might make more sense to look at how it's being used. So main, we have, don't worry about this here. String, string, string. Let's make one here. Employee is equal to null. So we've created an employee. Hold on one second. Let me. This will become apparent. This will become apparent when we do the dinosaurs. But it's common. Okay, this is an object reference that was created. The problem with this example is it does more than just show one concept. This is an object reference that was created, but it was no assignment to any reference because we know we can go new something. So we did here. What we did here is we asked for some user input to put some stuff in here. This is really E is equal to new employee, and the employee that's going to have his name, department, dependent, and pay rate that's being sent to it. And then up here we have the first name, last names being set to null, department 000. And then we're saying enter first name, enter last name, enter a department number. So we're asking for user input. And then in this do loop here, because it's demonstrating a do loop, it's going to say that we're going to parse an integer from this reading in. We're going to need that other file actually for this to work. And then if pay rate is this here, then do this here. And number of dependents is going to be put into here as well. And really what we're doing is we're just taking and creating an employee. And the employee has dependents, and the employee has, the dependents know about their employees. I know it's overkill. It's overkill. In fact, you know what? I hesitated. Huh? Yeah, when we create the employee, inside of the employee, we can say we have an array of dependents in here, and we're assigning dependents to employees. And the dependent gets created as a separate object. So we have, the dependent knows about the employees, and the employee knows about the dependents. So we have this going on.
Actually, it should be this way, right? The employee attribute itself should have an attribute called dependent.
It does.
Yes.
dependents. But they know about each other. Dependents know about employees, and employees know about dependents. So what we've really done here is kind of put objects inside of objects, but there really is just one level. There's just two levels. Actually, there's a third level. There's an object up here. It goes down to the person. So it's not as complicated as it sounds. It's just nested. So we have nesting. This is an array again, and you have to get a deal and deal book. Once you figure out arrays, we have 5 dependents maximum that we can create. And we can basically, in here, this is the constructors to create an employee, get an ID, get department. Same stuff as before. And then we can add a dependent. This main program isn't exercising everything. The main program, I left it kind of simple so that it will basically just create a couple of employees, and I believe it just adds one dependent in there. So we have add dependent method here. The add dependent is coming in. So if I run it, you kind of can see what it, oops, I didn't want to do that. I did the same thing before. I want to make it minimized. There we go. I need to put this other file in here. Let me show you this other file real quick. It's called a read console class. We need it in here. So I'm going to put this read console in here. Let's take a look at read console real quick. It's doing a try and a catch, which is doing exception handling, which I haven't covered yet, so don't worry about that. It's creating an instance of an object of type input stream buffer. It's calling the object instance ISR, which is going to be a new instance of it, which is going to take the string that's coming in from the system.in instead of system.out. So system in. The read buffer is turning it into a string automatically. So we're taking the buffer that's coming in from the system in, using it as a parameter to create a new input stream buffer, and then taking the input stream buffer and applying it to a buffer reader. The buffer reader turns it into a string. This is, again, on steroids for some people. But this is what you do in the end. This is a good example of Android development, actually. This is the kind of stuff you're going to write when you do Android programs. You're just making instances of objects and using it like this. So if I run this program, you can kind of sort of see what it does. Here's my output window. I have to run it from command prompt, or did I not run it? Let's see. Run. Oh, I'm not running it correctly. Run. Yes. Enter first name, Barb. Enter last name, Ecker. Enter department number 100. Enter pay rate, I don't know, $10 an hour. Enter how many dependents? Oh, let's go 2. Enter dependent's first name. Oh, let's go Bob. Mary. Oops, okay, that's Bob, Mary. Okay, here we go Fred, Wilma from the Flintstones. Excuse me. So now I have the information that's being printed out. What information is being printed out? Same stuff, it's just convoluted. What's being printed out is the employee 1, department 1, Barbara Hecker's name, pay $10. Here's dependent number 1, here's dependent number 2. If you follow through the example, actually, hold on a second. If you follow through the example, you'll see how the information is being passed back and forth between the different instances in the hierarchy. And then you'll also see how the dependent object is nested inside of the employee object. Assignment number 2 is not this hard. But for those people who want a challenge, and the reason why I'm showing this to you is this is more sophisticated. And after we get done writing assignment number 2, later on you can go back and look at this example and stare at it a couple of times, play around with it, and it might help you a little bit. This is common. This is the level that you're going to see out in industry in terms of using the concepts. That's a little bit past the basic level. This is intermediate level stuff. So it gives you something to examine and hopefully get comfortable with before. You usually have a month to do this before the next class meeting. is we're going to start with this. And then we'll create an array of objects, and we'll put other objects inside of other objects. As an example, happens all the time, you want a concept of a time. Are you going to reinvent the concept of time? Now you're going to create time.class. And then you can use time, my time, inside of another object, or date inside of another object, or person or dependent. And then these are sub-objects that are inside of objects. And then you're going to take all these objects and put them in an array. And then take all these other objects and cast them to different types and put them all in the same. Because aren't these all people? If I wanted to in this program, I can figure out how many people do I have? 3. I have me and my 2 dependents, Bob, Mary, and Fred Wilma. These are first and last names. And then I can kind of use them as people instead of, separate objects. We're going to get to denodes, don't worry about it. We're going to do it next. I'm going to cut this video so that I can keep it logically organized. But this is the rest. We went through everything that is inside of sample simple 2. And the read console is something to look at. You just saw a few minutes ago a program that ran that allowed me to do I/O. So it asked me for something, I entered something in. You may have noticed that the lines didn't go down correctly. It's meant to be run at a system console. The interpreter window in Eclipse is a little weird. If I were to run it here, I would actually have to change the directory. Actually, let's just do this. It's easier not to. So it's inside of JP simple 2, so JP-simple simple 2. And it's not compiled yet, so I just go start.java. Java C, start.java. Compile everything inside of it. Look for the main driver program. I think it's called payroll. So I go Java's payroll. And I'm going to get a problem. See my class loader wasn't working. It was working in the last one, but not in this one. So this is my class. My class path is not set. And so it should, however, if I could set my class path correctly, my class loader would actually find the files that I'm looking for. And when I'm looking for too many files, I can't find it because it's all located in the same directory. If I set it, actually I can go like this, set class path to equal, but then I have to figure out where am I in the hierarchy to set this current directory. I may have actually accidentally set the current directory in another form for the other, but I'm in a different directory in this window than I am in here, which is why it's not going to work. But anyway, long story short, it will also run from a command prompt if you have your class path set correctly. Or you can run it from Eclipse, but just remember the lines were kind of weird and it was asking me for input. So I'm going to end this video to logically break it.